Earth science and life science both have their fundamental rules and plenty of interesting concepts. But everything studied in those sciences is made of matter and energy. Matter and energy, in their raw forms, are studied in physical science. So everything studied in earth or life science must first follow all the rules of physical science. Physical science is usually broken up into two main branches, physics and chemistry. Chemistry studies the forms of matter and how they interact and change. Physics studies energy and how it affects matter. Since chemistry studies matter in its various forms, interactions, and changes, we first must understand what matter is. Matter is not everything, but it is pretty much anything that you'd call stuff, anything that can be touched or felt. Since some samples of matter are too small for your senses to realize that you're actually touching them, we use a different definition. A more accurate way to describe matter would be to say that it is anything that has mass and volume. By that we mean that it has inertia, or therefore requires some amount of force to move and also takes up space. Mass has two definitions, but we'll only work with the easiest one for now and introduce the other one a bit later. This easy definition says that mass is the amount of matter in an object, or sample of matter. The more stuff it is made of, the more mass it has. Volume, instead of being a measure of matter, is a measure of how much space the matter occupies. A balloon full of air and a balloon full of water will have the same volume, meaning they'll have the same dimensions and occupy the same amount of space. However, the balloon filled with water will have more mass. Mass and weight are different things, but if something is heavy, it also has a lot of mass. You'd measure mass by using an instrument called a balance. In class, you'll work with a specific type of balance called a triple beam balance. Basically, these work by comparing the mass of one object to that of another known object. It will have a place to put the object you're measuring, and then another side, or an arm, where you can add known masses. When you first put the unknown object on the tray, it will sink down like a seesaw with just one person on it. As you add mass to the other side, it will rise up. When the two sides are equal, are balanced, it will rise up to a level position. Volume is measured using a meter stick or ruler and some basic calculations, or by using a graduated cylinder. A graduated cylinder is a tube with markings on it, similar to what you'd find on a measuring cup in the kitchen. The markings indicate the volume of the fluid poured inside. To measure the volume of a regularly shaped object like a cube, prism, or pyramid, you'll be using some basic mathematical formulas. The basic volume formula is length times width times height. This is the formula to calculate the volume of a cube. All the other shapes have their own volume formulas, but they're all derived from this one. Most objects don't have a regular shape though. Have you ever picked up a pebble in the street that was a perfect cube or sphere? Probably not. So how do we determine the volume of these objects? To do this, we use a graduated cylinder. Take the graduated cylinder, partially fill it with water, and then make a note of the volume of the water. Next, place the irregular object in the cylinder with the water. The water level will rise. It does this because the volume of the object pushes some of the water aside. How much the water level rises tells you how much water was pushed aside, and resultantly, how much volume the object had. To figure out how much the water level changed, subtract the original water level that you noted earlier from the new one. The change will be the volume of the object. You measure volume in cubic meters, which is abbreviated as m to the third or m to the third power, if it is a solid object, and in liters, abbreviated as capital L, if it is a liquid or a gas. In the case of the graduated cylinders you'll use in class, 1 milliliter equals 1 cubic centimeter, or 1 ml equals 1 cm to the third. So if the water level rises 20 milliliters, then the object had a volume of 20 cubic centimeters. We are going to go over mass in a bit more detail and give the alternative definition. Originally, we said that mass is a measure of the amount of matter in an object. However, we also said that matter was anything that has mass. That's kind of like saying cake has sugar in it and sugar is used in cake. It doesn't tell you what either word means, just that they go together. So we need a better definition for mass. Mass can also be known as a measure of inertia, which is an object's tendency to resist a change to a state of motion. So what we're really saying is that mass tells us how hard it will be to make something start moving or stop moving. If something has a lot of mass, it will take a lot of force to make it move. If it has a small amount of mass, it will require a small amount of force. This means that we could change our definition of matter to be anything that needs a force to start or stop moving and that occupies space. One thing we need to make very clear is that mass and weight are not the same thing. Weight is not a measure of matter. It's actually a force, just like a push on a swing or a pull-up on a chin-up bar. Weight is the force of gravitational attraction between two objects, usually an object and the Earth. How strong the force of gravity is depends on the mass of the two objects. And since we usually weigh ourselves on Earth, and the Earth's mass doesn't change much, any change in weight, any change in gravitational force means a change in our mass. As a result, people tend to use the words interchangeably. An object with more mass than you will always have more weight than you, but that doesn't mean that they're the same thing. Mass is a measure of matter or inertia, and weight is a measure of gravitational attraction between you and the Earth. Your weight is different on the Moon than on Earth, but your mass is the same. Mass is constant no matter where in the universe the object is, and is measured using a balance and expressed in grams, which is abbreviated as G. Weight varies depending on where the object is in the universe, and is measured using a spring scale and expressed in newtons, which is a unit of force, and is abbreviated as N, or can be measured in pounds. To make things easier, we can summarize the mass and volume of an object by looking at density. Density is the ratio of mass to volume, so something with a high density has a lot of mass squeezed into a small volume. Think about the water balloon and air balloon again. The water balloon is denser than the air balloon because it has more mass for its volume. If you're helping someone move and you see two boxes, one labeled pillows and the other labeled books, you would probably prefer to carry the box labeled pillows because you know it's lighter. Both boxes have the same volume, but the book box has more mass squeezed into that volume, meaning it's denser, and you can expect it to be heavier. Other forces often get involved, but knowing an object's density can also tell if that object will float or sink in a particular solution. If you mix water and oil together, the oil floats because it is less dense than the water. If you mix sand and water, eventually the sand will sink because it's denser than the water. If this is the case, how could a boat made of iron float? We've had armored ships since the Civil War, but why don't they sink? The answer is that the overall density of the boat, including the air inside, is less dense than the water. Submarines use this principle to point their nose up or down to surface or dive. Density has a very simple formula. Just density equals mass divided by volume. Density is what is known as a derived unit. So the unit or label you would place after its numerical value is the unit for mass, G, or grams, divided by the unit for volume, cubic centimeters for solids, and milliliters for liquids and gases. Water has a density of 1 gram per milliliter. So 1 milliliter of water has a mass of 1 gram. Since it has a density of 1, anything with a density greater than 1 will sink, and anything with a density less than 1 will float. Thinking back to our boat or ship, as long as the total density of the ship is less than 1, it will float. If you know the density of an object, you can actually work backwards to find its mass or its volume. using basic algebra. As long as you know two of the values, you can always find the third. If that's too difficult, you can shortcut that by using the triangle shown. Just remember, going from left to right, dmv. If you have mass and density and want to find volume, divide the mass by the density. If you have density and volume and want to find mass, multiply density by volume. And one last time, if you have mass and volume and want to find density, divide the mass by the volume. Why does density determine floating and sinking? High-density objects sink and low-density objects float because of the combined action of two forces acting in opposite directions. The force of gravity, weight, causes objects to sink, while buoyant force causes objects to float. Weight, as we've already determined, increases with mass. Buoyant force, though, increases with the volume of the object. Whether an object floats or sinks depends on which is greater, the sinking force, gravity, or the floating force, buoyant force. So basically, it depends which is greater, mass or volume. Since density is the ratio of mass and volume, floating and sinking depend on density.